In this video, we're going to discuss piecewise functions. Piecewise function is a function that is defined differently over different domains. So an example of a piecewise function would be f of x is equal to 2x plus 1 when x is less than 1, and f of x is equal to x squared when x is greater than or equal to 1. Let's try graphing this function. Let's first start with the 2x plus 1 part. So let's graph that part in red. Whenever we're graphing a line, we start by the y-intercept, so which in this case would be over here. So this would be our first point, and we're allowed to graph a point there because when x is less than 1, then we have a point there. And then we go up 2 and 1 to the right. But over here, at x is equal to 1, our function is equal to x squared, so we aren't going to have a point over here. However, infinitely close to this point, like right over here, we are going to have our function defined as 2x plus 1. So we're going to have an open circle over here by x is equal to 1. And then when we connect these points, we're showing that everywhere in between x is equal to 0 and x is equal to 1, our function is defined as 2x plus 1. But at x is equal to 1, our function is defined as x squared, and we'll graph that part next. Now we want to continue our line going down to the left. So since our slope is positive 2 over positive 1, we could switch that to negative 2 over negative 1. We could go down 2 and 1 to the left. Down 2, 1 to the left. Let's just do one more. Down 2, 1 to the left. And now let's connect these points. And this would be our line, the line part of this function. And let's graph the x squared part. We'll graph that part in green. F of x is equal to x squared when x is greater than or equal to 1. So let's make a table to make it easier to graph. And let's choose values for x. We'll choose our smallest value is automatically going to be 1. Let's just choose 2 more. 2, 3, and that should be enough. 1 squared is 1, 2 squared is 4, and 3 squared is 9. Let's graph these points. At 1 it's 1, 2 it's 4, and at 3 it's 9. So our function looks like part of a parabola, and we thought it would because x squared is always a parabola, and it goes on and on and on in this direction, but not in the other direction. Notice that this graph is a function. Even though we have a point over here and a point over here, this red point isn't really a point. It's an open circle, so it's not defined there, and it would pass the vertical line test. If we drew the vertical line down, we would only pass through the graph over here, and not over here. However, if we would have had a closed circle over here by the red, and we would have had a closed circle by the green over here, then this function would not pass the vertical line test, because when we drew our straight line down, we would pass through the function over here, and through the function over here. This function is not continuous, as you could see. Piecewise function could sometimes be continuous. We could have a piecewise function like this. Now, obviously, this is continuous, and it is piecewise because there's a different slope over here, a different function over there than there is over here, but it's still continuous even though it's comprised of two different functions. Piecewise functions could also have more than 2 parts. Ours had 2 parts when x is less than 1 and when x is greater than or equal to 1. Piecewise functions could have 3, 4, 5 parts. For example, f of x is equal to x plus 2 when x is greater than 1, x when x is equal to 1, and x squared when x is less than 1. We could have a piecewise function with 3 parts, with 10 parts. We could also have something called a step function. A step function usually looks something like this. So you would read this graph as, when x is greater than 0 and less than or equal to 3, f of x is 0. When x is greater than 3 and less than or equal to 6, f of x is equal to 1. When x is greater than 6 and less than or equal to 10, f of x is 2. Notice when we have an open circle, it means that the function is not defined at that point, because let's say we would have a closed circle over here, this would no longer be a function because it would not pass the vertical line test, because when we would draw our vertical line down, we would pass through the function over here and over here. And that's important to realize when you have piecewise functions or step functions. Let's say you have a piecewise function like this. This would not be a function because it does not pass the vertical line test. If you would draw a straight line down like that, you would pass through the function over here and over here. But let's say your function would look like this, with an open circle over here. That means it's not defined over there. Then it would pass the vertical line test because the vertical line only passes through the function over here, and this is an open circle, which means that it is not defined there. Let's look at some region questions regarding piecewise functions. This is question number 16 from the August 2015 Algebra 1 Regent. Which graph represents f of x is equal to the absolute value of x when x is less than 1, and the square root of x when x is greater than or equal to 1. Let's graph this absolute value function and this radical function to see what they look like on the calculator. Y equals, and get the absolute value sign, we do alpha f2 and enter. We have an x, and then square root function, and we'll graph it in zoom 6 for zoom standard. Now the graph that we're graphing is graphing an absolute value function over the entire domain and the square root function over the entire domain. What we have to realize is that for our domain, we only have an absolute value function when x is less than 1. So that means we only have an absolute value function over here. And then after that, we have a square root function when x is greater than or equal to 1. So then our graph looks like this. So the green graph is how our graph is going to look. And if you look at the answer choices, you'll see that the correct answer is choice 2, because that's how our graph looks. We have a straight line going up left, and out to the right, we have this curved square root function. Let's look at another region question. Question number 7 from the June 2015 Algebra 1 Regent. Morgan can start wrestling at age 5 in Division 1. He remains in that division until his next odd birthday, when he is required to move up to the next division level. Which graph correctly represents this information? And then we're given 4 graphs as answer choices. And what we need to do is match the correct graph with what they tell us in the question. So what do we know? We know that he could start wrestling at age 5. Let's look at choice 1. At age 5, he could start wrestling in Division 1. So that looks correct. He remains in that division until his next odd birthday. So his next odd birthday is when he turns 7. Then when he turns 7, which is right over here, he can move up to the next division level. And perfect, he moves up to Division 2. Then at his next odd birthday, when he turns 9, he can move up to level 3. When he turns 11, he can move up to level 4. When he turns 13, he can move up to level 5. So choice 1 correctly represents all the information, and choice 1 is the correct answer to the question. Let's look at the other answer choices just to see why they're wrong. Choice 2. We know that in the question it says he could start wrestling at age 5 in Division 1. But over here at age 5, it shows an open circle, which means that at age 5, he's not wrestling anywhere. He only gets to wrestle when he's after age 5, when he's 5 and 1 day. So this is not the correct answer. Choice 3. We know from the question that he could start wrestling at age 5 in Division 1, so that's correct. At age 5, he starts wrestling in Division 1. Then by his next odd birthday, he gets to move up. But on this graph, it shows that at age 7, he's wrestling in Division 1 and Division 2. So first of all, this is not a function, because it does not pass the vertical line test. When we draw a straight line down, we pass through the graph over here and over here. And also, he can't be wrestling in 2 divisions when he's 7, or when he's 9, or when he's 11. So choice 3 is not the correct answer. And choice 4, when he's age 5, he's supposed to be wrestling in Division 1, but over here it shows an open circle, which means he's not wrestling in Division 1. And at 7, he's not either wrestling in any division, because it's 2 open circles. At 9, he's not either wrestling in any divisions, so choice 4 is not the correct answer. Let's look at one more region question. This is question number 2 from the June 2015 Algebra 1 Regent. The graph below represents a jogger's speed during her 20-minute jog around the neighborhood. Which statement best describes what the jogger was doing during the 9 to 12-minute interval of her jog? So the 9 to 12-minute interval is over here. And then we have 4 answer choices. So let's look at the answer choices. Was she standing still? We see that if we look over here, her time from time 9 to time 12, her speed was 6 miles per hour, so she could not have been standing still. Was she increasing her speed? That's choice 2. Well, from 9 to 10 to 11 to 12, she's always going 6 miles per hour, so she was not increasing her speed. Choice 3, she was decreasing her speed. Well, she stayed at 6 miles per hour, she was not decreasing her speed. She was jogging at a constant rate. She was. When she started at minute 9, she was jogging at 6. 10 she was 6, 11 she was 6, and 12 she was 6. So the correct answer is choice 4.